Hello, welcome to our paper presentation. The paper is titled as Density-Aware Personalized Training for Risk Prediction in Imbalanced Medical Data. My name is Zepeng Huo from Texas A&M University. So first of all, I will be giving this high-level understanding of our framework. I've broken down that into three key components, which is decoupling framework, density-aware laws, and the trainable cost matrix, and I'll go through them one by one. So first of all, we have this decoupling training to decouple the feature structure, which is the backbone, and the classifier, which is usually the last few fully connected neural network. So historically, this has been proven that classifier is very susceptible to class imbalance, but the feature structure is not. So to decouple the training can help to tackle the imbalance issues at the same time to extract very rich set of information, because we still want the feature structure to absorb as much information as possible. Secondly, the density-aware loss function is used to detect the minority class. Is aimed to be very highly personalized. This is because in biomedical data sets, usually the minority class is inherently heterogeneous, but the majority class is more homogeneous. What that means is that, the prediction of interest is mortality, and most of the patients will survive, and only a minority of the patients will eventually pass away, unfortunately. But because they have different reasons to be in the high risk range, they will usually have different reasons for the underlying driven factors, such as some patients will have heart attacks, some patients will have renal failure, and those can be of different reasons to drive them into this higher range. But the majority of the class of the patients are usually more stable in terms of the features, so they will be looking more similarly. Lastly, we have this trainable cost matrix. It's very dynamic to learn the penalty of type 1 and type 2 error along with the model parameters during the training. And this has been proven to be very novel and has not yet been seen other works for this imbalance issue tackling. So lastly, I will be introduce this framework Schematic. As we can see from the left to the right, we have this imbalanced data set, and we have two different sampling technique. One is batch sampling. The other one is imbalanced batch. Both of them will go through the feature structure, which is the backbone, but the balanced batch will only go to the balanced classifier, and the imbalanced batch will only go to the imbalanced classifier. Both of them will be trained with this density-aware laws. If you have interest, please come to our poster section for further discussions.